Hello everybody, welcome into another lesson. So today we are going to talk about graphing inverse trig functions. So up first here we have y equals the sine inverse of x. And if we remember right, the domain and range have switched places from the sine of x. So your domain of the sine inverse is from -1 to 1. Your range is -pi/2 to pi/2. So the sine inverse of -1 would put you down at -pi/2. Sine inverse of 0 is 0. The sine inverse of 1 is pi/2. So your graph would look something a lot like this. So there is the graph of the sine inverse. Now let's talk about the cosine inverse. So let's graph that. Alright, so we're going to graph the cosine inverse of x. Now, your domain's still the same, from -1 to 1, but if we remember, the range of the cosine inverse is from 0 to pi. So we have a different range. So we'll say pi is up here. Alright, so what about, if we put in -1 for the cosine inverse, that's going to put us all the way up to pi. If we put in 0, that'll put us at pi/2. And if we put in 1, that'll put us at 0. So your graph is going to look a lot like this for your cosine inverse, going from 0 to pi. So there is the graph of your cosine inverse function, y equals the cosine inverse of x. And then, of course, we got to talk about the tangent inverse. And for these purposes, we're only going to graph the sine inverse, cosine inverse, and tangent inverse. We aren't going to do the other inverse functions. There's really no point in it. So what is the domain of the tangent inverse function? It's actually all real numbers. So actually all real numbers is your domain. Now what about your range? Your range is from -pi/2 non-inclusive to pi/2 non-inclusive. So here's going to be pi/2, there's -pi/2. So those are going to act as horizontal asymptotes. Now, it would not hurt to put in some values here. So let's set up some triangles to help us ascertain some certain values here. Like let's do pi/6, which would be 30, do pi/3, which would be 60, set up some 30, 60, 90 right triangles, and then some 45, 45, 90 right triangles. I know these aren't exactly drawn to scale, but you'll get the idea. So that could aid us in helping to set this up here. So let's see, what if we put in, we take the tangent inverse of -1, that'll put us at pi/4, which would be right here. If I take the tangent inverse of 0, that's 0. If I take the tangent inverse of, well, that should be -pi/4 for -1. Tangent inverse of 1 would be pi/4. Okay, now, what else do we have here? So, if I want to take the tangent inverse of the square root of 3/2, So what the heck is the square root of 3 over 2? Or the square root of 3 over 3, I should say. What the heck is the square root of 3 over 3? Let me figure out what that is. This is where your triangles come into play. So it's about 0.58. So 0.58 is about in here. If we do the negative of that, that would give you about pi over 6, or negative pi over 6, I should say. And then if you did it in the positive, they give you about positive pi over 6. So your graph is going to look a lot like this. You're going to have a horizontal asymptote at negative pi over 2. Then you'll have another horizontal asymptote at positive pi over 2. So it almost looks like a cube root function for your tangent inverse of x. That's what you would get. You almost get what looks like a cube root function for the graph with your tangent inverse function. So we're going to do about 6 exercises here of graphing these. So what do we got here? Y equals 2 arc cosine of x. So y equals 2 arc cosine of x. Well, this is an arc cosine function, so our domain is still going to be from -1 to 1. Now the range, this is going to affect the range, because you have, if you have a coefficient on the function itself, that affects your range. That is a vertical stretching factor. So your normal range is, of course, going to be from 0 to pi, but you have to take that 2 and multiply both members of your range, which would really give you a range from 0 to 2 pi. So you've actually just stretched everything vertically. So 0 here, alright, so let's see, pi over 2, pi, 3 pi over 2, 2 pi. So 2 pi will be all the way up here, pi will be here, 0 will be here. Okay. So here's how we're going to graph this. Take your -1 for your arc cosine of x. So what is the arc cosine of -1? That's pi normally, right? But if you take that times 2, you would actually get 2 pi. So you'll be all the way up here. Now, what about the arc cosine of 0? That would normally be pi over 2. Take that times 2, you'll end up getting pi. Then if I take the arc cosine of 1, that would normally be 0 times 2. Well, that's still 0. That hasn't changed. So your graph is vertically stretched like this because you have that factor of 2. So there's the graph of y equals 2 arc cosine of x. All right. Y equals the arc sine of x over 2. So we have y equals the arc sine of x over 2. Now, if you have a change in the input of your function, if you have a change inside the parentheses, this is affecting your domain rather than your range. So we know the normal domain of the arc sine function is, of course, from -1 to 1. However, we need to set up an inequality. Take that x over 2, make -1 less than or equal to x over 2, and make that less than or equal to 1. You should get that -2 is less than or equal to x, which is less than or equal to 2. So your actual domain in this case is going to be from -2 to +2. So that's actually just changed your domain. So the domain is -2 to +2. Now your range, there's no coefficient on the arc sine, so your range is still going to be from -pi over 2 to pi over 2. So this is going to be a horizontal stretching factor, is what we're going to have. So let's go to -2. If I put in -2 for x, I would get the arc sine of -1, which would put me at -pi over 2 down here. Now if I put in 0, I would get the arc sine of 0, which is still 0. Then if I put in 2, I would get the arc sine of 1, which is actually pi over 2. So yes, my graph of the arc sine function is more horizontally stretched due to that factor of 1/2 inside of the arc sine, because that's really 1/2 x. I got about 4 more, then we're done with the lesson. F of x equals the arc sine of the quantity of x minus 2. Alright, so everything's going to be shifted to the right 2 units. Arc sine of x minus 2. Well, your normal domain is from -1 to 1. We got to set up another inequality of -1 less than or equal to x minus 2, which is less than or equal to +1, which means that 1 would be less than or equal to x, which would be less than or equal to 3. So your domain in this case is actually about to be from +1 to +3. Now, you don't have a coefficient on the arc sine, so that means your range has not changed. It's still going to be from -pi over 2 to pi over 2. So let's go ahead and put in 1. If we put in 1 for x, you'll get the arc sine of -1, which would give you -pi over 2. Now, if I put in 2 for x, that would give me the arc sine of 0, which is just 0. Then if I put in 3, that would give me the arc sine of 1, which is +pi over 2. So here's going to be my graph, and as you see, everything has shifted to the right 2 units. And then we have f of x equals the arc cosine of x plus 2. So we have f of x equals the arc cosine of x plus 2. So since we have a change in the input of the arc cosine, it's going to change your domain. Your normal domain of the arc cosine, once again, is -1 to +1. So set yourself up another inequality. -1 is less than or equal to x plus 2, which is less than or equal to 1. That would give you -3 is less than or equal to x, which is less than or equal to -1. So the domain in this particular case is going to be from -3 to -1. Now you have no coefficient on the arc cosine, so your range is still going to be from 0 to pi. Your range hasn't changed. changed. So everything has shifted to the left 2 units. So let's put in -3 for x. That would give you the arc cosine of -1, which is pi. So here's the pi. If I put in -2, that's going to give me the arc cosine of 0, which would be pi over 2. Then if I put in -1, that would give me the arc cosine of 1, which would be 0. So there's the graph of my arc cosine function shifted to the left 2 units. I got about 2 more, then we're done. Alright, so I have here f of x equals the arctangent of 2x. Well, what's the domain of your arctangent function? That's simply going to be negative infinity to infinity. Your domain hasn't changed. That's going to be negative infinity to infinity. If you take 2 with infinity, it doesn't change that. Your range also shouldn't change because we don't have a coefficient on the arctangent, so your range will be from -pi over 2 to pi over 2. The only difference is that 2 in there indicates a horizontal shrinking factor of 2. Well, let's start at 0. What's the arctangent of 0? That's still 0, right? Now, this time, if I put in, let's say I put in x being 1/2. If x is 1/2, that gives me the arctangent of 1, which would actually be pi over 4. So we'll put that right here. Then if I put in -1/2, that would give me the arctangent of -1, which would end up being -pi over 4. So as you see, this is going to horizontally shrink my normal graph of the arctangent of x. And then I still have horizontal asymptotes at y equals pi over 2 and y equals -pi over 2. So I've horizontally shrunk this a bit. That's really all that did. And I got one more and we're done. F of x equals the arc cosine of x over 4. So f of x equals the arc cosine of x over 4. So I have a change in my input, which is going to affect the domain. Your normal domain of the arc cosine is -1 to 1. So set yourself up another inequality. -1 is less than or equal to x over 4, which is less than or equal to 1. Which means -4 would be less than or equal to x, which would be less than or equal to 4. So my domain in this case is going to end up being from -4 to +4. So I've horizontally stretched this graph is what I've done. I don't have a coefficient on the arc cosine, so my range is still going to be from 0 to pi. So now we can proceed and graph this. So if I put in -4 for the x, I would get the arc cosine of -1, which would put me at pi. So that would put me at pi. Now, if I put in 0 for x, that would give me the arc cosine of 0, which would be pi over 2. Then if I put in 4 for x, that would give me the arc cosine of 1, which is going to be 0. So as you see, this graph is horizontally stretched by a factor of 4. So that is the graph of f of x equals the arc cosine of x over 4. So that's it for this lesson. The next two lessons will be based on something called the law of sines. So up till now, we've been working on dealing with right triangles to solve for triangles. Well, the law of sines will enable us to find missing angles and lengths of triangles that don't have to be right triangles. They could be any other type. So I hope everyone has a great day. Take care.